What I'm going to try and show you here is two different ways of writing the solutions to inequality problems. So the first one we're going to work with is interval notation. And with interval notation, you need a starting point, which is a small number, and an end point, which is the larger number. Okay, so we're going to start with the very first. These solutions that we've got on the left are the solutions to the last 4 examples that you worked on in class and that we have videos for. So if we look at this first one, y is less than or equal to -3, we have the shaded area which is to the left of -3. Now imagine if this is a number line. How far down does it go? Because it doesn't have an end point down here anywhere. Okay. On the upper side it stops at -3, but if we go backwards it keeps going forever and ever. Well, on either end of a number line we have negative infinity and positive infinity. Okay? Every number line goes from negative infinity to positive infinity, so we can always put those on either end of our number line. Okay? And hopefully that gives you a little indication of what's coming next. Because our solution to here, to this first question, y is less than or equal to -3, goes all the way from negative infinity up to -3. So we're going to have negative infinity to -3. Okay? And we separate them with a comma. So we start at negative infinity, we go all the way up to -3. Now the other thing we have to decide is whether to use brackets or parentheses. Now, since the -3 has a closed dot, a colored in dot, when the dot is colored in, we use brackets. Okay? When the dot is colored in, we use brackets. If we had an open dot, or if we have an infinity, either negative or positive infinity, we always use parentheses. So we used a bracket for -3 because there's a colored in dot at -3. But for infinities, we always use parentheses. So that's going to be our interval notation in this case. Okay? So this is interval notation, uses parentheses and brackets. Our set notation for this one, our variable in this case was y. So set notation is a little bit strange. What we do is we start off with a curly bracket. For set notation, we always start off with curly brackets. And we indicate what our variable is. In this case, our variable is y. And then what we do is we draw a vertical line. And we say that this reads the set of numbers, the solution is the set of numbers y. The line is read as such that. Okay, this line is read as such that. So what we've got so far is that our solution is the set of numbers y such that, well, then we just go back to the solution, such that y is less than or equal to -3. Y is less than or equal to -3. Now you might wonder about what the point of this is, and it's very technical, and I wouldn't worry about it too much, but I just want you to know that all it means is the solution is a set of numbers that are less than or equal to -3. Okay, moving on. Let's go to this next one. X is greater than 5. Well, if x is less than 5, again, we're starting at negative infinity and we're going all the way up to 5. So negative infinity to 5. Now the difference here is that we have an open circle at 5. Open circles are just like infinities. They're not included in your answer. And to show that, we use parentheses. Okay? So our solution here includes every number up to and just short of 5. But 5 itself isn't included. And that's why we use the parentheses. Okay, you might be able to guess what the set notation is for this. The variable this time is x, so it's going to be the set of numbers x, such that x is less than 5. Okay, and curly brackets for set notation. On the third example, from -4, x goes from -4 to -2. Our interval starts at -4. And it goes to -2. The infinities aren't involved here because it starts and finishes well away from the infinities. So we're going to go from -4 to -2. That's going to be our answer. Now the question is, what should we do with this? Do we use parentheses or brackets? And if it's colored in, if the dots are colored in, it's brackets. Okay, so -4 and -2 would be part of our solution. Remember, if it's brackets and if it's colored dots, the answer, those numbers are part of the solution. If they're parentheses, then the number there is not part of the solution. Now in set notation, the variable again here was x. Okay, so that tells us what our variable is going to be. So it's a set of all numbers x such that, and then we just copy this. For set notation, we just copy this. -4 is less than or equal to x is less than or equal to -2. Okay, and then we're nearly done here. This last question, x is less than 1 or x is greater than 6. If we look at the, if we look at the number line, it gives us a clue. So the first part of this goes from -infinity to 1. So this is a little bit more complicated. From -infinity to 1, and the 1 isn't included. So we're going to use that. And again, we're also going to use from 6 up to infinity. Okay, so from 6 up to infinity. Okay, and we're going to use union for those. Okay, that symbol means we're including both of these with this part and this part. Both form our answer. The set notation for this one, okay, set of all numbers x such that x is less than 1 or x is greater than 6. Now, there may be some disagreements over how I've written that last piece because the union comes from set notation, but it's not enough. I want anyone here to worry about it. Okay, so hopefully you can follow that and you'll be able to write your answer in any form of the notation. Once you see it written in graphical form, then you should be able to write it in interval form pretty quickly. Okay, set notation is also useful, but it's probably not quite as important. It's much more technical. But the interval notation with the parentheses and the brackets, that's worth learning. That's going to come back to you again and again. Okay, so hopefully that made sense.